So picking up where the last video left off, we were talking about Riemann sums as a way to estimate the area between the x-axis and a function. And if the function's rate of change, it tells us total amount of change. Let's say that we're dealing with a velocity of t squared for all time that's greater than or equal to 0. And we want to know where's the particle at t equals 2 if it started at 0. Bad spelling over there on my part. Starts. And so the simplest shape for us to use is a rectangle. Really the easiest shape because it's the simplest to find the area for. It does tend to take us, it is the shape that will take us more rectangles to get a good estimate, but it's quick estimates. So if we're dealing with t squared and I'm looking from 0 to 2, just can't get this out of my way right now. So here's a good graph of t squared. It's not perfect, but I just need its help. I'm going to just start with doing what I call 4 partitions. And by partitions, I just mean I'm going to estimate this using 4 rectangles. And if I'm going from 0 to 2, that means my rectangles are going to be 1/2 wide, because ideally I want to have them all the same width. So I'm going to start on the right-hand side to make it easier to see. So my first rectangle is going to be from 1.5 to 2. I have a width of 0.5. The issue now is the height. There are different ways I can decide what height this rectangle is. I could use the left-hand side of my rectangle, the 1.5, and go up until I hit the curve and say, this is my rectangle. In which case, my rectangle would be 1.5 squared, which is 2.25. Or I could use the middle of my rectangle, 1.75, and go up until that hits the curve. In which case, this is at 1.75 squared. Or I could use the right-hand side and go up until I hit the curve on the right-hand side, in which case this is at 2 squared, which is 4. So I have 3 different choices. So what we do is we pick one of them and we use it for all of the rectangles. So in this case, I'm going to use the left, the 1.5, not the midpoint, not the right. This is what's called the left rectangle approximation method, or LRAM, as I have up here. So left rectangle approximation method. And it's just saying I'm going to use rectangles where the left side of the rectangle determines the height. And those areas will approximate my total amount of change. So in this rectangle, the left side was 1.5. I went up till I hit the curve. And since it was at t squared, that's at 1.5 squared, which is 2.25. So that means the area for my first rectangle is 2.25 times 0.5, which is going to be 1.125. I then can move over to the next one. My next rectangle will be between 1 and 1.5. Because I'm doing LRAM, the 1 determines the height. So I go up until I hit the curve, and that's how high my rectangle goes. So it went up 1 squared, which is 1. So my second rectangle has an area of 1 times a width of 0.5. So I have an area of 0.5. My third rectangle goes from 0 to 0.5 to 1, so it has a width of 0.5. The left side, because I'm doing LRAM, goes up till I hit the curve. I go over, and its height is at 0.5 squared, which is 0.25. So its area is 0.25 times the width of 0.5, or 0.125. And then finally, my last rectangle goes from 0 to 0.5, so it's still 0.5 wide. The left end 0, I go up till I hit the curve, which is 0 squared, 0. So I have a rectangle with a height of 0, which I know sounds weird, but it does work for us. So a height of 0 times a width of 0.5. And I want to add these areas all together. And so I get the total change is going to be 1.75. So my particle moves 0.75. Or I'm sorry, not 0, 1.75. Come on. There we go. So now looking at my curve, I can see my rectangles are all underneath the function. So because my rectangles are all underneath my function, this is going to be an underestimate because there were areas, little bits of area in here, 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 and here that aren't covered by my rectangles, but are change, but it is part of the change that happens when the particle moves. Now, if I had used MRAM or RRAM, MRAM's a little bit tougher to make the decision, but RRAM, my rectangles would all be above, and I'd have extra area. That would be an overestimation. I guess I should say MRAM is midpoint rectangular approximation method. RRAM is right-hand rectangular approximation method.